Here are some examples of problems about graphing trigonometric functions. Problem 1. Find the period and amplitude of y equals 1/2 sine of x and graph it. We know that sine of x has amplitude of 1. This means that the amplitude of 1/2 sine of x is going to be equal to absolute value of 1/2, which is just a half. We also know that the period of sine of x is equal to 2 pi. This means that the period of 1/2 sine of x is also 2 pi, since the factor of 1/2 is not a coefficient of x, but a coefficient of sine of x. Now, if we wanted to graph this function, it would look exactly like the graph of sine of x, except it would be half as high. So it would look something like this, where this is a height of 1/2, and this is minus 1/2. We can also label pi here, and minus pi here to show the period. Problem 2. Find the period and amplitude of y is equal to secant of 3x and graph it. We know that for the secant function, the y value will go off to infinity as the x value approaches the asymptotes. This means that there can't be an amplitude since it's not bounded. For the period, we know that the period of just the secant function is going to be 2 pi. But here we have secant of 3x instead of secant of x. So we need to divide the period of secant by the coefficient of x in absolute value, and then we get 2 pi over 3 as the period. Now let's graph this function. These are the x and y axes, and secant looks something like this, with asymptotes here, and continues in this fashion. This will be at -1, and this will be at 1. And since the period is 2 pi over 3, these 2 points here are going to be 2 pi over 3 apart, so they will be at pi over 3 and minus pi over 3. Problem 3. Find the period and amplitude of y equals 3 cosine of 1/2 x and graph it. We know that cosine x has an amplitude of 1. So to find the amplitude of 3 cosine of 1/2 x, we can ignore the 1/2 x, but 3 times cosine of 1/2 x means we need to multiply the original amplitude by absolute value of 3. So we get 3. Now for the period, we know that the period of cosine x is 2 pi. Now we can ignore the factor of 3 in the front and consider the coefficient of 1/2 that x has. This means that we take the original period 2 pi and divide it by the absolute value of the coefficient 1/2. This will give us 4 pi, which is the period. Now the graph of this function will look just like cosine, but the scale will look a little bit different. So cosine will look like this, and on the other side like that. But this peak point here is now going to be 3, and this point will be at -3, and since the period is 4 pi, the distance between these 2 points must be 4 pi, so this has to be plus 2 pi, and this has to be minus 2 pi. Problem 4. Find the period and amplitude of y equals 2 tangent of 6x and graph it. Now just like with secant, tangent has asymptotes where the function approaches infinity and minus infinity. This means that there is no amplitude, since there are no maximum or minimum values. Now for the period, we know that tangent of x has a period of pi, unlike 2 pi for the previous ones. And this time, x has a coefficient of 6. This means we need to take pi divided by absolute value of 6, which is pi over 6, to find the period. And now we can graph the function. So the graph will look something like this, just like a normal tangent function, except these curves will be slightly steeper than normal since this function has tangent multiplied by 2. So we can label this as about 1, and this is about -1, and on the x-axis, one period past the origin is here, so that should be at pi over 6, and one period behind the origin is here, which is at minus pi over 6.